everyone, and welcome to the first episode in this year's series of the Ultimate Supply Chain podcast, where we dive deep into thought leadership matters on key supply chain topics. I'm your host, Louise Barber. I head up marketing here at DHL Supply Chain, and I'm thrilled to kick off this year's series with you. Today, I'm particularly delighted to welcome David Gray, who is the Client Director for EV Battery Solutions at Cox Automotive. We're going to be talking about everything related to EV batteries, sustainability, battery logistics, and so much more. Welcome, David. It is a real pleasure to have you on the podcast.
Thank you, Lou. It's my pleasure to join. As you know, we're very proud to be in cooperation with our friends at DHL. So really looking forward to this conversation and sharing hopefully a little bit of interesting insight, but also having a good topic of conversation along the way.
Definitely. So look, before we get deep into the discussion, can you just share a bit about your background and how you found your way into this fascinating industry?
Yeah, that's a great start point, I think. So
no pressure, fascinating industry.
Yeah, as my accent will give away very, very quickly, I'm from the West Country. I'm Bristol born and bred, albeit I live in Bath. And Bath is pretty much the starting point of how I found my way into the automotive industry. I was playing rugby over here to a fairly decent standard, and one of my rugby colleagues said, "What are you going to do after you've finished your economics and SIPS qualifications at the uni here?" And I said, "I haven't got a clue." So he said, "Hey, why don't you come and do some work for my dad?" And his dad was the service director for Kerridge, who were a DMS provider, and the rest, as they say, history. So I kind of moved through the DMS services, predominantly around technologies and platforms, and migrating to hosting. Then I joined Mannheim Business, which is obviously another business that's one of the businesses that Cox own, and then moved through that business in varying terms and have been there for 17 years since. So, and three of those, or 2.5, 3, have been with what we call the EV Battery Solutions business, which is an emergent business within our portfolio, where we obviously look after in-life management and activities associated with EV batteries. So automotive for a long time, very proud to have done so, really enjoy the environment, the challenges it brings, and obviously the very transformational nature of an industry that actually is very emotive. We're still very much in love with the automobile, which I hope continues as it keeps me fed and watered.
Definitely. First question, you mentioned rugby. Are you Bath Rugby or are you Bristol Bears?
I'm Bath through and through. I still have a season ticket.
Oh, interesting.
Yeah. I played there.
Interesting.
And then went back to play
Did you?
club. So yeah, so absolutely, yeah. Still Bath, still very close to the club, and a number of friends and players who I had the privilege of playing with.
Amazing. Well, listen, maybe we'll get back to that at a later date over a glass of Bath ale. Let's kick off and think about the industry we're talking about. You've mentioned how the automotive industry is changing massively. We've all seen that in our everyday lives. Can you talk a little bit about how electric vehicles have impacted that industry over the last couple of years?
Well, yeah, yes, with pleasure. But it's a very simple headline overview of that. It's affected almost everything. So it is arguably the largest transformational change within automotive since the inception of the internal combustion engine and the change from the horse and cart. Every single stakeholder and kind of business within the automotive space is affected by electrification, be that the OEMs themselves, the fleets that are obviously very prevalent in the UK and Europe, and less so in America, but still large numbers due to the location, dealers, insurers, salvage companies, remanufacturers who bring those internal combustion engines up, energy storage, of course, storage, logistics, and last and by no means least, the consumers themselves. This is a major transformation where significant aspects of the way they go about their work and the tools they need to do that, the training, the legislation involved, and the challenges with consumer adoption and migration to this new form technology are all significantly affecting everybody, including ourselves, as predominantly, you know, used vehicle handlers across that space. Our business itself is changing and having to refactor the way we do things, all with electrification in mind.
So yeah, listen, I've recently moved to a hybrid vehicle. I'm on the journey, and I've got to be honest, battery logistics. We use the term quite a lot within our organisation. I think sometimes we use it without really thinking about what it means to consumers. Drives me mad when I charge my car and then drive somewhere and I can't find somewhere to charge it to come back. Now I'm lucky because it's hybrid. But that's what we mean by logistics, isn't it? This isn't just about the production of batteries and shoving batteries in cars. It is so much more complicated than that.
Absolutely, and there seem to be kind of 4 or 5 big topics around consumer adoption that are being ran to as a challenge across the industry. But charging infrastructure is a major one, particularly if you don't enjoy the privileges of home charging, and that's many people, particularly when you start to look at large metropolises and at the centre of London, everywhere else, where it's probably impractical and very challenging and costly in comparison to having your home charger, the economics of it, to look at a charging process or a usage process, and we use this word a lot across the whole industry, commensurate with that of an internal combustion engine. So we're very used to having the comfort, the privilege. We know where the petrol station is. We know what the process is. We know invariably it's going to be working. We're not going to face that challenge with the charging infrastructure. And significant strides have been made, but even the payment processes and everything else associated are still something that is being addressed slower than I guess consumers would like, particularly, as I say, for those that are reliant on it.
And we're lazy. I want the convenience of going and filling up with gas or whatever, and making sure that I can drive straight away. And having to think about, I'm lazy. I'll be the first to admit it. But I think I've got a 27-year-old daughter. She is absolutely committed to a sustainable environment, and she won't have anything but an electric vehicle. And I think that generations are changing and that demand can only grow. Can you talk a bit, David, about technology? What are the advances? Let's get a bit geeky. What are the advances in battery technology that have been most significant in driving adoption of electric vehicles?
Well, there we've seen some super positive changes. So if I go through that 4, we talked around charging infrastructure. Well, actually, one of the other things was range anxiety, the charging speed, the challenges with charging to 100% of capacity, etc., of the battery.
Right.
And there's been significant advancements in that to address it. And actually, most batteries now that are in use or going to be coming into use have much more range, much more capacity for charging and better charging speeds. And that's built around the pack structural design, but also the chemistries within. So you'll hear lots and lots of acronyms in the EV world, and you'll hear around NMC, which is the predominant kind of battery technology in use today that's brought us to this point. And it's very dense. It's built with nickel, cobalt, magnesium, etc., and some other rare materials, so they're quite costly to produce. The LFP batteries, more abundant resources in terms of the lithium phosphate, and therefore costs are coming down, range is going up, charging speed also going up, and one really significant factor, costs are going down. So that means that those kind of B segment vehicles, A and B, so if you think something like a Volkswagen Up, if we use the Volkswagen range as a great example, they've just announced a vehicle only last week, 20,000 euros, so let's call it 17,000 pounds. Let's be on the positive side of the exchange rate. And that's a new entrant into the space that is hitting exactly where your daughter will be looking, or others, in terms of saying, well, I want to go on the EV journey. Currently, they're costly. Most of the models that are built to justify the investments and the costs are up in those higher segments. There's SUVs, those premium prestige sort of vehicles, and therefore are expensive. So it
Yeah.
challenges the adoption. But yet, significant amounts of both structure and design and kind of engineering of those batteries are being done, but also first and foremost, the chemistries are really helping us understand how we improve performance whilst reducing cost, which will be a massive, massive factor.
Definitely. And forgive a very naive question, but those different chemistries involved in the manufacture of the battery and the composition of the battery,
Yeah.
are they interchangeable? Can you swap one for the other?
No.
If you've got okay.
And
Right.
that in lies one of the challenges of the advancements of the technology. It is usually at the cost of repairability, or certainly is at the moment. So
Okay.
an LFP pack is bigger because it is actually less dense than the NMC pack, so it needs more cells. And what they're building is what they call kind of a cell to pack technology. And that cell to pack, so if you think today's packs are usually modularized, so lots of modules of cells within that are connected
Right.
through a series of technology, buzz bars we call them, that connect them up, plastics or thermal connecting technologies that mean that delivers all of the capacity in obviously a single pack. So lots of modules within the pack, configurable, I say configurable, repairable in terms of exiting a module, replacing that module with failure, doing lots of other clever stuff that engineers do in terms of balancing those modules and checking them, etc., and all that sort of stuff, and other tests to make sure that anything that's done goes out to the quality standards you'd expect. But in the new
Yeah.
technologies, they're having to put more cells in, so therefore they need as much space as possible, and that is eating up
Yeah.
what would historically have been the structure. So yeah,
Okay. Makes sense. It's a bit, I was thinking, is this as simple as, I used to have a diesel car. Now I've got a petrol car. Can I
yeah,
just swap one for the other? And of course you can't, because it's a disaster. And it sounds like the same is true here. One just doesn't work in the other just because of the way the car works.
yeah. We'd love, I think, as a world and the industry, that kind of uniformity across the packs, so that obviously you could see all of the economies of scale and efficiency that would bring across the ecosystem. But of course, it's a
Yeah.
competitive space with new entrants coming in and taking a lot of food off the table of the historic OEMs that are household names to us, certainly in the West. We see the Chinese entrants coming in with a difficult to argue, fantastic technology and a pricing strategy that will, I guess, drive the path to electrification, or the competitiveness of that path.
Yeah.
Yeah.
Definitely. And listen, I guess if you think about how long we've had a combustion engine, we are really, really early in the journey. And here I am wanting to change the battery in my car that I've only had a year. So listen, I think everybody's exciting to be on the journey, not least because of the implications for the planet and the sustainability argument. Can we talk a little bit about that? What are some of the most promising initiatives that you're seeing in the EV battery industry around that sustainability agenda?
Well, of course, there's a headline associated with all of this effort to the path to electrification, and that is obviously decarbonisation, net zero, sustainability, and a kind of new buzz phrase, I guess, to the automotive industry in terms of circularity, in terms of obviously everything in terms of the production path, from sourcing the materials through to recycling and the phases within. And there's lots of these very similar but uniquely designed by our experts in marketing in terms of demonstrating that circularity journey. And the positive, I guess, aspect of those technologies that I aforementioned is they're highly recyclable. So that
Right.
although you have to extrapolate some of those very precious and materials from the ground, and that's not without its environmental impacts, and that has to be recognized and understood. Once they're out of the ground, the process of basically recapturing the value from those materials is already progressing at speed with great processes today, but ever evolving processes to support that, so that they minimize their environmental impact through that process. The design of these vehicles is not without thought to its recyclability, and there is legislation that is tracking that to make sure that those objectives are achieved. So, the sustainability goals within this are clear, and from the outset, that has always been the kind of model that has been thought about from a path to these new energy vehicles. As I say, not without work that needs to be done, but there are great companies really, really looking at that, and a lot of them we're proud to say are in the UK. Looking at new processes for recycling. They're also looking at how we handle the movement, the storage, the almost every single adjacent factor to the production path of that battery, because that is really important. If you start to think around moving those batteries where they might need to be recycled, moving them through their process if they encounter any damage or there's an event that requires repair, maybe it's a recall event that's happened already on some of these vehicles and batteries. How do you do that really, really efficiently with those stakeholders in that process also aware and trying to do their best to serve the planet and the people within it better, with that kind of net zero objective in mind? And that's one of the reasons I'm proud to work with DHL. Having your infrastructure, having your mission and capabilities really aligns with the Cox missions and objectives around leaving the planet in a better place than we see it today.
Definitely. And that's what I meant when we were talking up front around the whole battery logistics. This isn't about battery production. It's not about battery usage. It is about logistics. And, we joked a bit up front again about being from the West Country. Bath and Bristol, we've both got those electric scooters in the centre of our towns. 3 years ago, it used to make me laugh watching, I shouldn't laugh, but I did, watching the little guy go around picking up the scooters that people have inevitably left to one side and putting them on a truck with diesel pumping out the back of it. And you think, oh no, it's like putting water in the bath with the plug out. But that has changed over the last couple of years. That's now, back in my day, it was like a little electric milk float. And now the guy is going around on one of those, and you can very much see that they're thinking about the whole logistics process and not just the provision of of those electric vehicles in the centre of a town. Interesting what you say about the focus on production of those batteries. What about disposal? Where does disposal come in? What's the life of these batteries, and what happens towards the end of their life?
Well, the great news for anybody listening who's considered that they're really robust. Whatever chemistry is out there today, they're actually very robust. So failure rates are low. Degradation rates on those batteries are also low. So we kind of see across a 8 to 10 year cycle a degradation of around 10 to 15%. So those batteries are really solid pieces of kit.
That's really efficient, actually, isn't it?
Really efficient. And, that is with some learnings that will be applied around the charging processes of these batteries. So one of the benefits of LFP is you can charge it to 100% to 100% without the impacts to degradation that you'll see in the NMC batteries. So this is a really positive thing in terms of people not having to overthink around their charging processes. But the failure rates are, and let's talk to NMC. We see those with the kind of design they are today around 3% across their entire life cycle of the vehicle park, and that's not including things like insurance damage and write-offs or events, as I've said, a recall event. So pretty low, still high volumes when you start to think around of an electrified vehicle park, or 50% in 2030, 2035, etc. But the LFP ones are better again. We're seeing that at around 1.5, 1.2% failure rates, with projections of what we know today through handling tens of thousands of batteries that we've seen come through our business over its 11 years of existence. So we're kind of seeing that the batteries are robust, the capacity within them remains fairly high across the vast majority of the technologies and the design. So therefore, they've got a second life use that comes into play, and that will invariably be energy storage. We struggle to generate enough power to serve our needs today, and that is kind of a geopolitical challenge as much as it is a infrastructure challenge. So these batteries will have a second life utilization where we can store energy and serve that back to the grid and or to the public as required. And last but by no means least, obviously, you look through there at that recycling piece, as you've said. So, in terms of kind of the recycling focus, it is significant. Um, it is secondary. There's no two ways about that. Obviously the clue's in the title of what OEMs do. They're manufacturers, so they're looking at the
Yeah.
manufacturing strategies, the adoption, their investment they're making is massive. But legislation and already existing technologies mean we can extrapolate significant amounts of value from those batteries during the recycling process, and projections will be that will be or high 90s, 100% in some cases, with really environmental processes for that as well. Today they use kind of heat and water and chemicals to do that.
Uh-huh.
Hydro and poly processes that are doing recycling, and they really work. They obviously, we shredders take the batteries down to the raw materials, and they extrapolate the varying chemical materials within, and then they go off for these processes to bring back the actual energy cathode processes within that. So it's growing, and a factor of about 50 is needed for it to even serve the batteries that we believe will be in use on our projections today. So it's going to be a very growing
Amazing.
industry and competitive.
And are you seeing, so you've talked a bit about, the kind of repair, the recycle, the remanufacture, that you're really trying to dial up within this ecosystem, I
Yeah.
guess. Are you seeing OEMs integrating those principles into their end of life battery strategies? Is it something they're thinking of up front? How does it work with the OEMs?
What they are, and they're thinking, that legislation will drive some of these behaviors, but they absolutely are. They're
Right.
thinking around circularity. They're thinking around whole vehicle circularity and not just the battery within. It's a significant cost factor for the vehicle itself. The first initial vehicles, we're talking around 40-50% of the battery price. With those cost reductions we're seeing, that's coming down, which is positive again for the consumer and for the industry as a whole. They're looking at it in terms of how do we maximize our return on investment on their battery investments through the vehicle's life cycle. And obviously,
Mm.
the first place for that is to keep it in its primary use for as long as possible. So it's designed for automotive grade and usage, with lots and lots of
Yeah.
other things factored into, not just the chemistry and construction of it. You think around the technology that's involved in it, what it's serving, empowering within the vehicle, the battery management systems, and that is evolving as well. Those technologies, as we start to think around, if we think of Elon's world where we have autonomous vehicles driving us around, that's going to take some power and processing power to drive and those behaviors. And we all love air conditioning, heated seats, and the comforts that our vehicles provide
Yeah,
us. That all needs powering as
that's
well.
true.
But so that usage and keeping it in its primary optimal use for as long as possible delivers the maximum return on investment. Not least when I talked around the fleet businesses, they adopted EV at pace because of the obvious kind of personal benefits, taxation benefits, etc. Incentives that would mean that the drivers who drove fleet vehicles, or their, I guess, corporate fleets out there in the world as well, were obviously incentivized significantly to adopt electrified vehicle park. They're thinking around secondary leases, extending those vehicles, thinking around the residual values of those vehicles. So if that battery has, a an extended life, it means the vehicle has an extended life as well. So therefore, that they can keep that vehicle on the road. Then you think around to say the reuse. So there's a market out there for plenty of people who will be looking to buy batteries for energy storage. That tends to be the second tier of value. And then recycling, albeit such a critical stage, and every battery will end up being recycled, is kind of the lowest return on investment at this precise moment. So that kind of circularity process is designed around basically, keeping, and like, perhaps understandable, you'll remember when we were in school, we saw that green triangle that said repair, reuse, recycle, and the same is
Yeah, yeah,
very,
yeah.
it was stuck on every bin. And which, given myself, I probably totally ignored and threw my can of vanilla Dr Pepper or whatever the trend was at the time. But yeah, it's a logical process that we've known and is being thought about and applied from a OEM perspective, right from the outset of the consideration. But as I say, first and foremost, they've invested an awful lot of money, tens of billions in refactoring their factories, their product strategy, their go-to-market
Yeah.
strategy for these products. So they're focused on all of the kind of really, really key topics that will help enable consumers to buy and use their vehicles, but also this parallel track of kind of circularity, repair, reuse, and recycle is thought about. And the recycling obviously offers another value if you think around the critical chemicals and the effort to mine and buy those, and the competitive nature of
Yeah.
that, some of that being geopolitical as well, means that they're thinking around vertically integrating those raw materials back into their production process. So if they bring this
Yeah. I mean, I guess it's a bit.
straight back into the machine.
Yeah.
Yeah.
I guess that evolution is a bit of human nature, isn't it? You've got a bit of carrot and a bit of stick.
Yeah.
The initial carrot was financial incentives. You've got legislation with the stick, and as those two things are kind of moving forward in parallel, you've also got culture, where that cultural change, where younger generations are definitely voting with their feet in terms of this is the right thing to do for the planet, and organisations, as you say, changing their fleet policy, for example, because it's the right thing to do, not just because they're either incentivised or legislated to do that thing. It is fascinating. Do you see much difference around that? The challenges of battery logistics and the legislation situation, is there much difference across the world? How does it work in different countries, different regions, different parts of the planet?
Yeah, I mean, we tend to be obviously from a kind of still an EU-led sort of legislation sort of perspective. We still look there and more prevalent than some of the stuff we're seeing locally. The US, for example, have obviously state legislations that kind of vary to a degree. They're all fairly emergent and blurred in some cases. So that's one thing I see consistently across the markets. There's some areas that create some thought, in terms of waste handling, in terms of battery conditions, in terms of obviously a battery that's damaged and or in a red state, as we would call it, from green, amber, red, in terms of the conditions of the batteries, new batteries or a repairability battery. Everything associated with battery logistics and battery handling has some complexity within it and some vast differences to that of the internal combustion engine, unsurprisingly. There's ADR compliance, there's the fact that these are often big and heavy pieces of equipment. So the full EVs have what we call skateboard packs within them, and they're often a meter in length, 900 wide, can weigh 600 to 900 kilograms. So they require significant machinery to handle them. They require a specified and compliant packaging to make sure that obviously they're in a state that won't connect or combust in terms of any way. So there's lots of safety regulations around that. There's legislation around obviously the labeling of this. That is fairly consistent across the board. Obviously, we see nuances in varying markets and regions. So the UK being an island, obviously with it, shipping those batteries adds massive complexity. So taking them off the island back to often where there's repair capabilities and or that's a route they want to get them back to a holding depot so that they'll hub those up so that they can go back to wherever they need to go back to. That adds complexity as well. We're seeing that it's kind of an area of the industry that needs thought and some, I guess, more profile at almost the very top table, even at some government legislation and other areas to make sure that people are doing the right things with them. And there are obviously those that are, because they are, the risks involved and the company credentials and brand kind of considerations are obviously really, really thought about, and DHL are an obvious person to talk to that. You handle an awful lot of batteries today, you store them today, and that again needs everything from permissions, compliance, legislation, fire suppression, thermal monitoring. You start thinking around these things as large difficult to handle, lots and lots of legislation and compliance, but also, we know that the risks involved with handling, lithium-ion batteries or, automotive-grade
Definitely.
batteries.
What are those? What are some of those specifics, David? Because we're not just chucking a load of batteries in a warehouse. That is not what is happening here. What are some of the considerations that are specific to handling, moving, storing, maintaining that battery life cycle in the logistics system?
Well, we can start with logistics first and foremost, because it's one of the significant factors in the in-life management or end-of-life management of batteries, because it's still complex and costly. If you want to move one of these a long way, it's not without costs and challenges involved with it. The aforementioned kind of just handling of it alone, picking that battery up and putting it on the back of the appropriate truck or delivery.
Yeah, they're heavy things.
Very heavy, yeah. So you need a Moffat truck, or you need a forklift to be at the location and or with the truck. Some don't fit on the back of the trucks. They need curtain side trailers just because of the configuration of the pack and the dunnage around it. But so logistics is really, really a significant factor in particularly the OEMs and the battery OEMs life cycle considerations. So obviously they need to think around where they can store them. So you need obviously the infrastructure to serve that, because you want to minimize the distances traveled, not only for the cost involved of picking one up and moving them around, but in a repair kind of process, you want speed of getting a battery that's in a good state and equal to or greater than capacity, or a new pack back to wherever the failures happened, pick up the failed pack and bring that back to a repair center, for example. So the speed of that process is important. So having all the tools and the tracking that's involved in that, and of course the connected capabilities. So how does that fit within the circularity process? So are you working with a repair agent? Are you working with a recycler to be able to move those efficiently and as kind of cost efficient as well in that process? So it's the scale, everything comes back to the obviously permissions, legislation. You think insurance companies want to know forensic detail about what you're doing with these batteries and where you're going to be holding
Of
them,
course.
how you're going to be looking after them. You then think there's obviously legislation that comes in that will be governmental permissions, etc., in terms of ensuring that you're handling the batteries with the care, so that the people turn up that start working those facilities or touch any aspect of those batteries, be it in the pack or out of the pack, go home the same way they came into work, and rightly so. So safety is paramount through all of that. But it
Definitely.
is that is kind of why DHL have the superpower that they do, in terms of having those EV centers of excellence that are running to all of the challenges involved with storage, handling, and obviously the logistics of those packs as well, to serve new packs, damaged packs that need repair, and obviously packs that would be considered as waste, or dismantled packs that would be going off into recycling processes. So yeah.
So we definitely see this as a category of logistics, an emergent category and a really important category. What's happening to prepare for the future of this category? Are people being trained in this specifically? Are there how are we preparing the EV and battery logistics experts of the future? What are we doing to bring them up to speed?
Yeah, there's new training methodologies coming in, and we're seeing it as a very emergent industry in universities. So our location in the UK is based in Rugby, and that's again not by just luck. It's by a little thought. You've got the University of Warwick there. You've got the Faraday Institute not far from there as well. You've got a lot of kind of electro-propulsion or new energy kind of battery industry leadership and emerging talent coming from that space, because we see it across the industry, particularly automotive, where obviously the nature of technicians within that is they're quite fluid in their movements across the brands, processes, so they need new expertise and new training, because the tools they'll be using are drastically different. And not without cost or complexity again. So we're starting to look at
Mm.
high voltage battery training. We're starting to look at, lid off activities that they could serve themselves for the batteries within dealerships to reduce movements, reduce costs, and
Wow.
support all that circularity. So it is, and I think the SMMT quoted it. They see this as almost a 50,000 job generation opportunity across the industry as a whole, in terms of,
Amazing.
and that's for the UK. Looking at where we're going to see new skills required, we're going to see new companies emerge to serve the whole circularity journey and EVs as a whole. And so training is paramount. Again, safety top of that list in terms of training when it comes to these
Definitely.
batteries. But ultimately, yeah, something that the industry really recognizes and is really, really running to. You'll see new jobs, new activities popping around this all the time. And the thing that we like is that we're seeing the opportunity to retrain people with kind of parallel skills that we've come across from industries that have energy storage within their capabilities. Some technicians or operatives that we see, hey, there's a great opportunity for you to move into a new growing space with jobs that, hopefully excite you and afford you new opportunities.
Definitely. I mean, it is fascinating, isn't it? How different this industry is from the old automotive industry. I popped the bonnet on my car the other day. My dad was an engineer, so I'm quite happy tinkering around with an engine. I popped the bonnet to have a look at the oil. It took me 20 minutes to find it.
Yeah.
And that's going to be the future, isn't it? You're not going to be popping the engine to mess about with the oil anymore. You're going to be somebody's going to go into the bonnet and just change the battery, and that'll be it.
Yeah. Well, hopefully it's few and far between. I mean, the service process for electrified vehicles is also changing. Within a dealership.
Yeah.
We talked to right at the outset the whole ecosystem. So the approach and model to servicing a vehicle is still in the process of changing, because actually it's exactly as you're alluding to. It's drastically different to what it was in terms of
So
there is
different.
no oil change, but there's other things that still need to be done on that vehicle to maintain its kind of health and safety and condition on the road and ongoing value. So, but that is
Yeah.
the battery will be diagnostically led. It will be done through tooling that is looking at its state of health, its condition, the module, how they're balanced, etc., within the vehicle, making sure that it's delivering its charging capacity in the way it should do, not overcharging, not the speed of it, etc. And that will require like diagnostics tools, cycling machines that can run the battery up and down to be able to test how quickly its capacity is being charged, etc. But it's definitely something that's an interesting thing, particularly for those who love the internal combustion engine. That's in truth served us very, very well. This is not about
Definitely.
looking at it and saying this is terrible technology. It's evolved fantastically well to deliver high value and efficiency as a tool to serve transportation. It is, as we know, the what comes out of the tailpipes that is driving this process to an electrified vehicle park. And you referenced your daughter earlier. I have a similar challenge. I talked to this on a number of occasions before. My daughter, I dropped her off at school, and she's, as they have these kind of pin badges, chair of the sustainability, whatever it is. And my current hybrid, much like yourself, was
A gas guzzler.
ridiculous petrol 400 plus brake horsepower car that I like the sound of when I turned it on. And she was like, "You can't drop me off
And the
outside
smell.
with this." Yeah, exactly, with this. And I'm like, "No, you're right. I can't." So, yeah.
So look, we've talked a bit about the past. We're starting to think about the future. Where do you see the future? Is there going to come a time when there's solar panels on the roof of the car that are driving the engine? What's next? What's the future like
Well,
in this arena?
there absolutely is. There's a company in Germany, and forgive me, I want to say Sonos, but that's the speaker maker. It's like SONS or something like that. That's just gone
Right.
nuclear from a shares perspective in Germany. Like its value's just grown up, and they've just signed off like proprietary technologies to almost retrofit solar panels on the tops of transportation trucks, and also on,
Amazing.
yeah, so and on vehicles and on other things, to basically say Right? All these trucks that are on the road, if you could just fit these to the top of them, there's a lot of real estate that would have solar panels on them, and to be able to support charging a battery pack that can then return back to the grid, or power refrigeration units, power, the truck
Yeah.
itself if it's not an electrified, if it has some level of electrification, blah blah blah. So that of course we'll see, and we see this in the world today. And there's thoughts on this, some good, some bad, in terms of obviously the amount of solar farms that are popping up everywhere to be able to support what the aforementioned challenge of getting power to our grid. We know
Yeah.
there's not enough of it, and we know through the worldwide events that the ability to secure energy is very, very geopolitical at the moment in terms of its thinking and its thoughts. So, yeah, in a future state, the chemistries will continue to change. The construction will continue
Mhm.
to change of batteries, all with those kind of thoughts in terms of delivering power, range, so energy density again, range, charging speed, cost, and getting the critical materials within. So sodium ion is being explored right now, and that's one of the kind of emergent technologies within this space. And it's abundant, sodium. You don't have to go through some of the environmental impacts and challenges of extrapolating those critical raw materials to produce those batteries. So we'll see
Yeah.
strides being made continually, which is going to present some challenges for those who want to repair or handle these, because it's changing technology and changing
Change
tools.
again. Yeah.
Yes, exactly. So that we're not on that kind of a world where, like as you alluded to earlier, that we know what an internal combustion engine looks like. And yes, they evolve and there's new technologies, and I wouldn't dream of taking the top half of an engine off like I used to in an old car, to, like you say, with your dad, to clean the spark plugs and check the oil and etc. in the new
My
world.
God.
But yeah, figuring out how to just get the choke at the right thing to start it, when you used to do that in an old car. But yeah, it's so they'll continue to change. They'll continue to change, and for the good of everyone within the whole ecosystem of the battery and the vehicle that it obviously powers, and transportation as a whole. We see that through buses, through large
Mm.
transportation, etc., in terms of trucks on the road. They're only a tiny percentage of those are electrified at the moment, or even using new energy in any state, whether that be hydrogen or other energies that are, we hope, run in parallel to help serve and support that sustainability goal that we kind of all on that mission to hopefully achieve collectively as an industry, and as a kind of adjacent industry as well.
Amazing. We've talked about the fact that Cox Automotive and DHL Supply Chain are in cooperation to see the future of battery logistics. What is it? Can you just encapsulate for us, what is it that makes the two organisations and our relationship bigger than the sum of the parts?
It's a great question, Lou. First and foremost, the reason that we're in cooperation with DHL is we saw a cultural fit. We saw a mission to serve the planet better, and obviously enjoy the privileges of two very large organizations, people, and their infrastructure within. And we saw the natural fit in terms of the challenges that we talked to briefly around kind of making sure that we minimize movements of those large battery assets, and the speed of those movements, to make sure that we could repair quicker, handle quicker, and support OEMs, be they vehicle or battery OEMs, in their objectives around the battery life cycle. Your infrastructure, we're privileged to take some space in your EV Centre of Excellence within Rugby, that affords us what we believe is a unique proposition in enabling us to offer, a central singular solution that supports the movement of the batteries, the repair and remanufacture of those batteries, and taking that understanding and applying it to the future model of, as you say, kind of battery logistics, but also automotive processes that support EVs. So we very much see the sum of that whole far greater than its individual parts, but also, as I say, very much working in cooperation with a company that has, a sustainability at the heart of everything it does, and looking first and foremost at our customer objectives to make sure that we're, really, really driving value throughout the process.
Definitely. And listen, we mentioned when we were chatting before we started to record, I hear our account teams, our developers talk about our relationship with Cox Automotive with so much pride. So I think you're right. I think there's a really good cultural fit there. And it's great to do something that we know is making such a significant positive impact for the future. So look, David, thank you so much for sharing your valuable insights with me today. It's been great to talk to you. It's been great to learn about this fascinating part of supply chain development and development in the ecology, actually, of the world. Not to make it too big. This is a really massive subject that is going to change everybody's lives. Also great to have a Bristol boy on the podcast. So thank you for that. And apologies, readers, if David and I lapsed into accent there. That's what happened when you get regional parties together. Thank you, listeners, for joining us today. We would love to hear what you thought about this episode of our podcast and more. So please share your feedback on our page or connect with us on social media. Until next time, we'll be back with another engaging topic in supply chain logistics. Thank you so much for joining us.